This project is on zebra mussels and their effect on lotic and lentic systems by Sanjeet, Mike, and Roger.
Most sources report zebra mussels originate from the Black and Caspian Sea, and they quickly spread from there throughout Europe before finding their way to North America and the Great Lakes in 1988. Dr. Carol Stepien of Cleveland State University compared the genetics and divergence patterns among the zebra mussel populations in North America to their native counterparts in Eurasia. Stepien compared 174 zebra mussel samples from 7 locations in North America and discovered that the invasion of the zebra mussels in North America appears to have been founded from many sources in northwestern and north-central Europe. This chart illustrates the origins of the mussels sampled. Lake Superior's populations had the closest genetic link with the founding populations from the Rhine River, while the samples from Lakes Huron and Erie seemed to be related to those from the Netherlands and Poland. Lake Ontario showed Poland as a founding species, and the Hudson River mussels appeared to be different from all North American samples except Lake Superior's. First, we're going to talk about how they got here to North America and how we can try to prevent them from spreading further. The most popular theory of how the zebra mussel was introduced to the Great Lakes was in the ballast of ocean-going ships traversing the St. Lawrence Seaway. A ship would reach port in Europe, unload their cargo, and take up ballast to maintain stability for their trip back to North America. This water pumped into the ballast tanks of the ship contains some of the native marine life, including zebra mussels. When the ship reaches the St. Lawrence and the ballast is no longer needed, it is then pumped out, releasing the zebra mussels and other foreign marine life to the waterway. Another way they were transported over is on the anchors and chains of the ships. The adult zebra mussel can survive out of water for several days or weeks if the temperature is low and humidity is high. Chain lockers provide temporary refuge for clusters of adult mussels that could easily be released when the oceanic ships drop anchor in freshwater ports. The main way they spread once here is by attaching themselves to recreational boats, on the hulls, anchors, anchor chains, motors, in the bait buckets, and even on the boat trailers themselves. Basically anything that contacts the water could possibly have contact with the zebra mussels, which are then transported from lake to lake throughout the boating season. The best way to prevent the spreading of zebra mussels is for boaters to inspect, clean, and dry their boats after use in one lake before entering another lake. This should include removing plants and animals from your boat, trailer, and accessory equipment, such as anchors, centerboards, trailer hitch, wheels, rollers, cables, and axles, before leaving the water access area. Drain your live wells, bilge water, and transom wells before leaving the water access area. Empty your bait bucket on land, never into water. Never dip your bait or minnow bucket into one lake if it has water in it from another. Also, never dump live fish from one water body into other waters. Dump any leftover live fish you have onto the land when you're preparing to take your boat out of the water. The zebra mussels can't live very long when they're out of the water, especially in the hot sun. Wash your boat, tackle, downriggers, and trailer with hot water when you get home. Flush water through your motor's cooling system and other boat parts that normally get wet. If possible, let everything dry for 3 days before transporting your boat to another body of water. Other options, such as anti-fouling paints containing copper or tin, are effective in preventing zebra mussel buildup, but their use is banned in Michigan and restricted in other states because they can harm other aquatic life.
Attachment of zebra mussels to man-made structure poses financial and safety concerns to people. They are opportunists and will attach to most hard surface materials. Water and wastewater facilities are susceptible to the zebra mussel invasion, as most materials are composed of metals and concrete, which are good attachment surfaces for the organism. They plug intake and outflow pipes, restrict flow-through screens, and damage expensive power-generating turbines. Globally, several studies have been conducted to mitigate the spread of zebra mussels. Electric current can energize metal components at sensitive areas to promote an inhospitable environment for the organisms. Potassium chloride can be added in lentic waters to kill zebra mussels via absorption. The chemical is a salt and therefore kills the organism once it enters the digestive tract. Chlorine can also be used in the same manner, but both these methods cause undue harm to non-invasive aquatic species. Hot water under pressure can be used on and around lock systems to rid boat hulls of the pests. Boats must be lifted clear of the waterline and sprayed with hot water at 54 degrees Celsius to kill adult mussels. 68 degrees Celsius is needed to kill animals in larval form. This technique is very expensive due to the energy required and also depends on the expertise of the washer. Potassium-infused paints are also being tested to kill mussels that attempt to attach to painted surfaces. Upkeep and water level fluctuations make this process difficult to justify. Studies have begun using fiberglass-based mesh screens to encase intake and outflow pipes. Zebra mussels prefer hard surfaces to adhere to and therefore avoid many flexible porous materials. It was discovered through tests that larger pore spaces between 3/4 of an inch to 2 inches are effective in stopping the spread of the organism. It was originally theorized that the different mesh materials would be the limiting factor for attachment, but it was soon discovered that pore size had more of an influence. During the summer of 1989, Monroe, Michigan was nearly shut down due to zebra mussel infestations. The mussels plugged the intake pipes of the local hydro facility so severely that schools, hospitals, and residences lacked the energy supply to serve daily needs.
When controlled for size and seasonal effects, zebra mussels are useful indicators of metal availability, parasites, and pharmaceutical products in the river. Many characteristics of the zebra mussel that make it an ideal choice as a bioindicator are its abundance, longevity, sedentary lifestyle as an adult, which is always fixed to a substrate, and its high filtration rate, which is approximately 1 liter per day for an individual, and especially its ability to concentrate certain chemical contaminants such as metals, PCBs, PAHs, and organic compounds in aquatic lifestyle. Long-term data indicate that phosphorus in the central and east basin of Lake Erie is not stable. In fact, there was a decrease in concentrations from 1992 to 1995 and an increase in 1996 and 1997. Environment Canada research suggests that increasing phosphorus could increase the presence of zebra mussels, but also the fluctuations in mussel populations could in fact be influencing phosphorus concentrations. Long-term monitoring has shown that lake bottom oxygen levels have experienced considerable variation, and there is little evidence to suggest that zebra mussels are having any significant impact here. Researchers have shown that weather is an important factor in explaining variations. Heavy metals are a concern to freshwater mussels due to their ability to cause mortality, disrupt enzyme function, and alter filtration rate, also reducing growth and changing behavior. Because freshwater mussels exhibit suspension and deposit feeding behaviors, heavy metals may be available to unionides through both the water column and streambed sediments. However, the overall bioavailability of metals is complicated and influenced by a suite of factors, including metal concentration and speciation, water column chemistry, redox potential, particulate matter, and flow regime characteristics. Cadmium is a common pollutant found in mine drainage, industrial discharges, insecticides, fungicides, and urban runoff. Generally considered highly toxic to aquatic life, and the effects of cadmium have been evaluated by zebra mussel toxicologists under both laboratory and semi-field conditions. The accumulation patterns in adult mussels as the process of concentration to high levels is rapid without direct toxic effects. Detoxification by metal-binding proteins will require energy and resources which are drawn from energy and nitrogen pool of the animal. A delayed effect will occur in which the population size diminishes due to the concentration of energy and protein causing energy exhaustion. Elevated levels of copper in the aquatic environment may come from a variety of sources including mine drainage, coal ash effluent, industrial discharges, and urban runoff. Recent studies and data compilations suggest that freshwater mussels are among the most sensitive aquatic taxa to copper. It also should be noted that a significant amount of variability have been observed among the individual responses unionides exhibit to copper. Further investigation, the toxicity of copper to the early life stages of freshwater mussels by assessing exposures to brooded, released, and encapsulated mussels. Brooded and encapsulated mussels exhibit little sensitivity to copper exposure. Zinc is commonly discharged into surface waters as a result of mining activities, industrial processes, and urban runoff. While studies suggest zinc is not as acutely toxic to freshwater mussels as copper or cadmium, it may accumulate to high concentrations in surface waters impacted by mining, waste, or industrialization. At high concentrations, zinc may elicit sublethal responses or mercury contamination in surface waters may result from pesticides, hazardous waste disposal, waste incineration, and fossil fuel combustion. Mercury is a concern in health problems in humans and wildlife. Evaluations of the acute and chronic toxicity of mercury to the early life stages of zebra mussels have a lethal concentration of 50% of the population at greater than 107 micrograms of mercury per liter, and was reported during a 24-hour exposure. Anthropogenic sources of chlorine include wastewater treatment plants and industrial facilities. Chlorine is generally considered highly toxic to most forms of life and is commonly used as a disinfectant. Evaluated that the toxicity of a total residual chlorine to the early life stages of zebra mussels shows that the mean of the lethal concentration to 50% of the population range from 70 to 220 milligrams for total residual chlorine per liter during a 24-hour exposure. The study also reported reduced growth in juvenile mussels at concentrations as low as 20 milligrams during a 21-day chronic exposure trial. Insecticides, herbicides, and fungicides are common contaminants in both rural and urban settings. Scientists estimate that approximately 1.1 billion pounds of pesticides are spread in the United States annually. Zebra mussels exhibit an array of tolerances to current use pesticides, identity of the contaminant, and length of the exposure. The evaluated toxicity of malathion, a commonly used mosquito and fruit fly insecticide, to the early life stages of zebra mussels, showed trials yielding lethal concentrations ranging from 7 to 375 milligrams per liter during exposures from 4 to 48 hours. Assessed toxicities of various current use pesticides on zebra mussels were researched. The zebra mussels and the juveniles were found to be highly sensitive to chlorothalonil, propiconazole, and pyroclosteropin. Glyphosate is one of the most widely used herbicides today. The toxicity of several forms of glyphosate and its formulations add a surfactant to juvenile zebra mussels. Reported 24-hour effective concentrations were as low as 3 milligrams per liter and 0.6 milligrams per liter. Reported 96-hour effective concentrations for juvenile mussels were recorded at 5.9 milligrams per liter and 3.8 milligrams per liter for Roundup. I hope you enjoyed our interesting facts about zebra mussels today. The mitigation techniques are varied as zebra mussels expansion is highly dynamic, and until an environmentally responsible method is discovered, the zebra mussel will continue to persist. Thank you very much, and thanks for listening. Have a